Hello everyone, welcome to the course C, Performance Over Time. On behalf of the teaching team, I'm going to address your questions posted in the AskProf forum. We appreciate your questions. Some of them are quite interesting. I selected three questions to be addressed in this video. The first question is about the real wear. One of the course participants asked about the standard and criteria to select the real steels and to meet the requirement of the lifespan. Actually, in different countries, we use different standard and norms. For instance, in the Netherlands, we use a European standard, but there's also American standards, Russian standard, Chinese standard, and also the standard from UK. And in those standards, it has been defined what for different purposes, what type of materials should be used. For instance, it can be the political real steel or the magnetical real steel, and also the different real profiles. As shown in this board, you can see some profiles, different type of real profiles. Some of the profiles are the USC 60, some of them are USC 54, and we can also see this is a grooved profile is for the tram. And for different real profiles, they can also provide a different support stiffness to the train, to the wheel. So they can be used in different purposes. They are all defined in the criteria and the standard. I have already provided a link in the forum where you can find more details about this standard and norms. And the second question is about the maintenance of and the renewal. One student asked if the difference between the long wavelength and short wavelength irregularities. One of our instructors have already provided the answers and also provide the pictures to demonstrate the answers to show the difference between the long wave and the short wave irregularities. And in this feedback video, I would like to also provide some examples of the short wave and long wave irregularities. For the short wave irregularities, such as the real joint and the switch and crossings, where we have a gap in geometry, and that may then cause the 2-point contact. And one typical example of the long wavelength irregularity is at the transition zone. We can experience the ride comfort reduction at the transition zone because of the long wave irregularities. And the third question is about the let me see. The third question is about the fatigue limit. It's about the occurrence of a fatigue. The students ask if the fatigue is relevant to this mean value, because in the course we provided an example that the mean value is 0. That is a 0 mean case study. The load is the load amplitude follows a sinusoidal wave, and the amplitude, the average level is 0. And the students ask if this amplitude mean average is not 0, but minus 300, for instance, a negative stress, if that can still cause fatigue. Actually, if the occurrence of fatigue doesn't depend on this mean value, but the fatigue limit, as we also illustrated in this lecture in the course of week 3. Because the fatigue or the fracture of the material is initiated by the cracks, and the cracks is caused by the plastic deformation accumulation. So when the plastic deformation happens, when the yield strength or this fatigue limit is reached and can be accumulated, then the fatigue may happen. So although this value is a negative, here I interpret this negative as a direction of the loading. So for instance, in the wheel rule contact, when the wheel is traction, we can consider the shear stress as positive, and when in the braking case, the shear stress is negative. So we can have both positive and negative stress. Regarding the amplitude, it can be it can be either high or low. If it reaches the fatigue limit, then this plastic deformation accumulation will happen and the crack will be initiated, then the fracture may happen consequently. And another determinant factor is the range of this variation of the stress change. So we call this has been described in the Basquin's law in the week 3 lecture. The delta sigma defines this factor. We can see from the Basquin's law that when this delta sigma is larger, this change of the amplitude is larger, then we can expect an earlier fatigue. So these are the answers to the 3 questions you have already posted in the forum, and we appreciate your input, and we hope we can see more questions in the coming weeks. And good luck with the following study. Bye bye.